Okay, Assalamualaikum brothers and sisters. We meet again for another Pspice tutorial. So this time the schematic will be about the inverting operational amplifier. Okay. So the op-amp is actually a chip. So you can see here, this is a diagram of an operational amplifier chip. It has 8 pins, and then you can see the pins are all labeled. Okay, so in your theoretical class, you only see this circuit symbol, kan? But actually, in your hands-on experiment, you're going to see a chip, and you're going to connect accordingly based on the label. Okay, so in your manual, for the inverting, it looks like this. So that's why we label the numbers here. These numbers corresponds to the labeling of your operational amplifier chip. Okay. Okay, so I have already created a project. I named the project as operational op-amp inverting. So that's the name of my project. Okay, so in order to add your op-amp, because it is a specific device, so the name is 741. The library is eval. Okay, and students normally make the mistake of adding this op-amp, but actually that is not correct. Alright, you need to find this one, UA741. Okay, so this is the correct op-amp that you're going to add. So I'm just going to click there and add this here. Okay, so let me zoom a bit. So you can see, in order to match this with the schematic here, okay, so the negative or the inverting terminal is at the top. Okay, so what you can do is you can do a mirror vertically. Yeah, so you can see when I do the mirror vertically, okay, the negative is at the top and positive is at the bottom. However, take note on number 4 here. Number 4 is connected to the negative supply, and number 7 is here at the positive supply. Okay, so either way, you just have to make sure that you connect correctly to the numbers. Okay. Okay, so let's start with the other components. So I will start with the DC power supply. So DC power supply, the library is source, right? So let's find it, VDC. So one is at the top. So number 4 should be the negative one. So I'm just going to rotate so that the negative is there, and then the positive one is at the bottom. Okay, and then this one should be just 15 volt. Okay, because I have already connected to the negative terminal, so just put the magnitude. Okay, for the bottom one, for pin 7, that one is straightforward, just put 15 volt as well. Okay, because it's the positive terminal, so just put 15 volt. For this one, is the negative terminal directly connected to pin 4. So this one, just take the magnitude. Okay. Right. So now we can connect to pin 4. Okay. So you need to connect until you see the red dot. It means that it is already connected. Okay. Next is the ground. So just going to connect this together to the common ground. Ground is another file here, capsim 0. Okay, so I'm going to put my ground here. Right, so that's one. Okay. Next is the resistor. Okay, so for resistor, the library is analog. Okay, so I'm going to add 2 resistors. One is over here, and one is for the feedback resistor. And you can see here for node 6, okay, I cannot just leave it like this. I have to put a load so that the circuit will be closed. Otherwise, I will have a floating node. So I'm going to add another resistor. I'm going to make it vertical. I'm going to connect at the output, node 6. Okay, right. Okay, so for inverting, the gain is minus R2 over R1, or in this schematic, it's minus RF over R1. So let's say I'm going to put 10k here, so that you're going to have a gain of -10, right? Okay, I'm going to create a ground here. Okay, I'm going to create another ground there. So node 3 should be connected to ground. Okay, the non-inverting terminal. Okay, and this node should be connected to node 6. Okay, hold on, let me do this slowly. Maybe you can't see this. I think I better close this for a while. Okay, right? So now you can see better. Oh. Okay, so the output should be connected to ground. Okay, right? So basically your V out will be measured across your R3, right? And the inverting terminal is connected to R1. Okay, the feedback resistor should be connected at node 6. Okay, right. Now you need to make sure that there is no node here. Okay, you just drag it so that it will pass this portion of your circuit, because if you stop here you will have this node, and that is wrong because this is directly connected to 6. Okay, so you need to be careful when you connect this kind of circuit, right? Okay, so I think that's done. Next is the input signal. So let's say the input signal is a sine wave. So again is a library source, and I'm going to put V sine. Okay, I'm going to find V sine. Right. So I'm just going to connect this to ground again. So connect to R1, and this one just straight to ground like this. Right. And this one is 0. Amplitude, let's say I'm going to put 0.1 volt, or basically 100 millivolt. Okay, frequency, I'm just going to put 1 kilohertz, and the AC component is 0. Okay, right. So this capacitor here, I can include this in the schematic, but because it's just a schematic and I just want to simulate, I will choose to not put this here, because this is just to because the capacitor here is actually for you to remove the noise. This is what you're going to put in the hands-on experiment, but for the simulation purpose I'm not going to put this capacitor, right? So I think I'm ready to simulate. Let's create the simulation profile. When you create the simulation profile, op-amp inverting sim. Okay, so it's going to be a time domain simulation. So it's 1 kilohertz. So I want to see 3 cycles, for example. So 3 millisecond, and let's make it smooth this time. So 0.01 millisecond. Okay, so apply and okay. So I hope this works. Let's run the Pspice. It's an error. Okay, why there is no plot? Oh, I should put this here now. Okay, so now I can run. See? Yes. Okay, so you see the input is 100 millivolt. The input is green, so it is green, and I want to see the output. The output is red, and I place the marker at the output node, node 6. So because it is 100 millivolt and I multiply with -10, the gain is -10, so I will get a -1 volt output. Okay, so you can see here, this is the 100 millivolt, and this is the -1 volt. Now in order to see the values, so I'm going to teach you something new here. It is called cursor, and you can display. Okay, so this is the display for the input signal, and you can see the value for peak value. So the peak value here is here 99.961 millivolt. Okay, and then if you click for the output one, okay, you can see here I highlighted the red one. So you can see that this is the cursor for the output signal. Alright, so for this signal, I'm going to see the minimum value, right? So you can see here the minimum value is minus 0.9987, which is approximately minus 1 volt. So when I divide the output over the input, I will get approximately minus 10, which is the gain, minus R2 over R1. So that's how you can play with the cursor. Alright. Okay, so another thing that I would like to inform you is on how you want to copy this response and paste it in your Word file or PowerPoint. So you just need to click here at window and copy to clipboard. And normally we want to see a transparent background. Okay, change white to black. So the numbers here will be black in color. So let's see. So this, and just click OK, and let me just go to a PowerPoint and just paste, and you can see that I have the response here. Okay, so now you have your response here, and you can use arrows to label something like this. Okay, so you can label this as output and label this as input. Okay, and you can select all and group. That's it. Okay, that's how you can present your work. Okay, so that's all for this tutorial, and I hope that all of you will stay safe and stay healthy and stay at home. Okay, Assalamualaikum. Bye.